How do you interpret thermal imaging data for conduction? Imagine being able to see heat flowing through a solid object just like a visual map. That's what thermal imaging does. It captures infrared radiation emitted by surfaces, revealing temperature differences. When it comes to conduction, understanding these images helps us see how heat moves inside materials. Conduction transfers heat through molecules vibrating or electrons moving from hot to cooler areas. The thermal camera detects surface temperatures, which reflected the heat flow happening inside. If a material conducts heat well, the temperature changes gradually across its surface. You'll see smooth color transitions in the thermal image. Sharp changes or abrupt color shifts suggest poor conduction or thermal resistance. Hotspots are areas that are significantly warmer, often indicating where heat is concentrated or where there might be a defect. Cold spots, on the other hand, are cooler areas that could signal insulation issues or material inconsistencies. Different materials conduct heat at different rates. Metals like copper or aluminum show uniform temperature distributions because they transfer heat efficiently. Insulating materials like foam or rubber show sharp temperature differences, highlighting poor conduction. When analyzing thermal images, pay attention to boundary conditions. For example, where heat enters or leaves the object influences the pattern you see. Contact points with heat sources or sinks create distinct temperature gradients. Watching how the image changes over time can tell you how heat propagates through the material. This is especially useful for transient conduction analysis. In practical terms, thermal imaging helps identify insulation failures, structural defects, or overheating components. For electrical equipment, hotspots can signal potential failures before they cause serious problems. To interpret these images accurately, remember that conduction involves heat transfer by molecular vibrations and electron movement within solids. Infrared cameras visualize surface temperature, which is directly linked to how heat moves inside. By understanding these principles, you can read thermal images to spot conduction issues quickly and clearly. This makes the science of thermodynamics more accessible by connecting theory with real-world visual data.